My name is ROWENA HARRISON. I'm currently doing a PhD on the interactions between dissolved organic carbon and hydropedology in Cathedral Peak. So the overall aim of my study is to help understand the different hydropedological behavior and flow paths of three separate catchments where carbon is stored more frequently in different wetlands of these catchments, and how much carbon is being removed from the catchments via watercourses. This will hopefully aid in filling in the gap of knowledge scientists currently have on understanding the role of grassland ecosystems in water carbon cycles in natural and semi-natural areas. So just briefly, the study is taking place at the Cathedral Peak Experimental Research Catchment Sites, and these are part of the SEA network. 3 similar catchments were selected for the study, and these catchments are similar in shape and size, but present different histories and land management practices. These catchments are named catchments 3, 6, and 9. So briefly, the methodology. So 28 piezometers have been installed throughout the 3 catchments, and water samples are taken from these piezometers as well as the weirs on a monthly basis. The water samples are filtered and then they're sent to the University of Burgundy in France, where they're analyzed for particulate organic carbon and dissolved organic carbon. I've also taken a number of soil samples from the piezometer locations, and laboratory analysis is ongoing at the University of the Free State. The analysis includes a number of things, such as particle size distribution, water retention characteristics, as well as chemical analysis, such as organic carbon, cation exchange capacity, and pH. So I've also installed 2 spectral probes in the weirs in catchment 6 and 9, and these analyze DOC, total organic carbon, turbidity, electrical conductivity, and temperature every 15 minutes. So far there's been only a few measurements as they were installed in June this year, but initial results indicate that the waters of C6 and C9 have similar TOC concentrations with ranges between 0.6 and 1 milligram per liter, and DOC concentrations between 0.25 and 0.5 milligrams per liter. So it's just a graph from the spectral probe showing the DOC concentrations between catchment 6 and 9. So as you can see, it's fairly low levels of DOC, but as soon as there's a precipitation event, you do get a spike in DOC concentrations, with a larger spike in catchment 6 as compared to catchment 9. So because of this, future work includes precipitation samples will be collected before and during storm events. The samples will be analyzed for DOC and POC. I'm also testing samples for stable isotope signals, and that's planned for the near future. And it's hoped that these results will be utilized to determine the contribution of wetlands to carbon cycling and DOC export at a catchment scale. Thank you.